right, so what I'd like to know before we start, has anyone done the nature of the roots at school? If you have done nature of the roots, put a yes or a thumbs up in the chat. If not, just put a thumbs down or a no. Okay, so lots of yeses so far. Abdullah, you have raised your hand. Have you got a question, or did you just mean to put the thumbs up? You can unmute if you have a question. If you don't have a question, you can just put your hand down. Abdullah, are you going to ask a question? Yes. Let's hear it. Gone. Okay. So that's great. And you all have done quadratic equations last term. And quadratic equations, if we just remember again what a quadratic equation is, it's set apart from other equations because it's got certain features. It's like us as people. We are different from each other because of certain features. So a quadratic equation always has a squared term in it, an x squared term. And there's a constant term and, there's a middle term with an x and then a constant term. Now, these two, the bx and the c, those are optional. Those don't need to be there. But the x squared, the minute it appears in an equation, that makes it a quadratic equation. Now, who of you recognizes this thing here? Put a thumbs up in the chat if you recognize it. Yeah, Kuchli says yes. Patejo says yes. Loveland, everybody, yes. This is our formula that we use to solve quadratic equations that cannot factorize. We can solve any quadratic equation with this formula, but specifically it comes in handy when the quadratic equation cannot factorize. Then we use that. Okay. Now, this name, roots is just another word for x values. So if someone's talking about the roots of the equation, they're basically talking about the x values or the solutions to the equation. So all quadratic equations have roots, and normally there's two roots, and that's just the x values. When the equation is 0, it's important, this is an important bit that sometimes gets left out, that for this to be an equation, it needs to be equal to 0. Sorry guys, just again, please remember to keep your mic on mute. Now, when you get to drawing graphs and doing functions, which will happen this term or sometime later on, you will also see that the roots are the x-intercepts of the graph. So a quadratic function, if we draw it, it's a parabola shape. And these 2 points where the graph cuts through the x-axis, those are actually the roots. Okay, so roots have a few meanings. It's the x values. It's when the equation is equal to 0 and we solve for x. And it's where the graph of the equation cuts through the x-axis. But what we're going to do today is we're not going to solve equations. We're just going to describe the nature of the roots. So when you describe the nature of something, you describe what it is like. What can you say about it? What is it like? So when we determine the nature of the roots of an equation, you do not solve the equation. You're just going to investigate what is it like. And for our investigation into what it is like, we are basically going to go back a few years to where you were in grade 8 or grade 9, and you did the number system. And you learned about the fact that the numbers we deal with in our number system is called the real number system. And then you also learned, well, there's another number system called the non-real number system. And Non-real numbers are basically numbers that do not exist in terms of how we define real numbers. And that's stuff like the square root of -2, and if you divide something by 0. So those numbers fall outside our number system. We call them non-real numbers. Real numbers are typically rational or irrational. Irrational numbers are numbers like pi, the square root of 2, anything that's got endless decimal places. So if you put pi into your calculator, pi equals, you'll see that there's endless decimal places. Root 2, root 5, basically the square root of any prime number, those are all irrational. And then we get to this part here. So don't confuse irrational with non-real, okay? Irrational numbers are very much real. They just behave differently to rational numbers. Rational numbers make a bit more sense if you can think about it like that. And it's basically any number we can write as a over b. So 1/2, 3/4, anything as an integer, -5/6. Those are all rational numbers. And part of the rational sort of subsystem is the integers, the whole numbers, and the natural numbers. Okay. So when we describe the nature of the roots, we are basically going to describe them in terms of the numbers that they are. Are they rational? Are they irrational? Are they non-real? What are they? That's what we mean with the nature of the roots. We're not going to say what they are specifically, give them values. We're just going to describe them. And we're going to describe them in terms of these words: rational, irrational, non-real, etc. Okay, so a quick little warm-up to get you thinking. Which of the following numbers is irrational? So work each of these ones out. You can use your calculator and then say which one is irrational. Put it in the chat as soon as you're done. Which one is irrational? It will be good to have your calculator. You can work out quickly all the different square roots. Some are saying D, some are saying B. Connor says B. Lots of B's coming through. I wonder if we can justify that. Why do we say it's B? Someone's saying B and D. So let's look at square root of 16. That's 4. That is most certainly a rational number. It's got no endless decimal places. It's just 4. And then we do the square root of 1.6. And we put it on our calculator, and immediately we get lots of roots and things. And if we look a bit further, it gives us that it's 1,2649. And I would say that has got endless decimal places. 1,600 is 40. And the square root of 0.16, we're going to see is 2/5 or 0.4. Okay, this is very much rational. And this is rational. But this is definitely irrational. So our answer here is B. Okay, nice. Okay, so B cannot be written as a fraction. It's not a perfect square. Yeah, 1,6 is not a perfect square. But 16 is, 1,600 is. D, be careful, D is definitely rational. It is a terminating decimal. It's 0.4 and 2 or 2/5, 2/5. That is a rational number. Okay. Right, so that's the rational, irrational, non-real numbers. How does that pertain to what we're doing this evening with the nature of the roots? Okay, so when we look at any quadratic equation, in standard form equal to 0. Endless, what do you mean by endless decimal places? Well, put into your calculator 1,2649 and you'll see that the number your calculator gives you is it just carries on. It doesn't what we say terminate. Okay, so a terminating decimal will be something like 0,4. Boom, end of story. But the square root of 1,6, and you'll see on your calculators 12649, and then it's got more decimal places after that. And normally your calculator won't show you all those decimal places. 64, you see, it has many decimal places, sometimes endless, like pi as well, and it doesn't follow any pattern. It just there's nothing rational about it. It's actually just decimal places without any specific pattern to it. Okay. If you want to, you can put into your calculator pi. Where is pi on this calculator? You can also put in an easy one is square root of 5. So the square root of 5, if you put that one in, you get 2,23606. And then again, lots of decimal places after that. But if you put in the square root of 25, you get 5. That's a rational number. Square root of 25 is rational. Square root of 5 is irrational. Okay, so I hope that answers your question. Let's get back to our discriminants. So if you hear the word discriminant,
how's your Xbox game going, yeah?
And if you hear the word delta, Ms. Label, can we just mute the person who is speaking in the background? Thanks. If we have delta and we have the discriminant and we have this little triangle, that all means the same thing. It means the discriminant. Now, what is the discriminant? The discriminant is just this part of the quadratic formula that stands under the square root. That is called the discriminant. So delta is always b squared minus 4ac. B squared minus 4ac. And it's the part in the quadratic formula that's going to tell you what the nature of the roots is, depending on the value that we work it out to be. So b squared minus 4ac comes from the quadratic formula, and its value determines the nature of the roots. Now, if we look at the nature of the roots, again, how do we describe the roots? There can be 4 situations. The first one is if delta is smaller than 0, and that means that the roots are non-real. It doesn't exist. And why doesn't it exist? Because if the number under a square root is smaller than 0, so if this number that goes under the square root in the quadratic equation is a negative number, so say it's -4, that's non-real. That's the first thing I reminded you of when we looked here at the non-real number system, that a negative square root is non-real. Okay. So if delta is smaller than 0, it's non-real. The roots will not exist. It means that there are no roots. And when you do the graphs of quadratic functions, you'll see what that means actually. What does it mean if something doesn't have roots? It's got no solution. And when you do graphs, you'll take that a bit further. So if delta is equal to 0, so it can happen that you work it out and delta is equal to 0, and that means we have 2 equal real and rational roots. So the roots are equal, real and rational. If delta is greater than 0, there are 2 real roots, and it could be rational or irrational. And then if delta is a perfect square, the roots are rational. Okay, so maybe you want to take a screenshot of that, or maybe you have it in your book already somewhere. But this is important stuff. This is what we're going to need now as we carry on and we actually determine the nature of the roots and we investigate further. Okay, so make sure you have that information handy. And so if delta is greater than 0, the roots aren't equal. No, it has to be a perfect square. So it has to be greater than 0 and a perfect square for, no, the roots are equal if delta is equal to 0. Then the roots are equal. And yeah, so if it's greater than 0, then the roots are not equal. So the condition of delta being equal to 0 means that the roots are equal. Alrighty. So delta b squared minus 4ac, and it can fit into these 4 categories. How are we going to work it out? Most of you have done it in school, so you might already know how to do this. So we've got our first equation here. First thing is it must be in standard form. Is it in standard form? Yes, it's equal to 0. So we can say, what is A? A is 1. I always suggest just doing this part so that you don't make a mistake. So A is 1, B is 1, and C is -1. So we start off and we're going to work out delta, b squared minus 4ac. And then we substitute into that formula our a, b, and our c. So the a, b, and c comes from our quadratic equation. B is 1, a is 1, and c is -1. And then delta is 1 plus 4, and that is 5. So delta is equal to 5. Where does that fit in? It means that delta is greater than 0. So our roots are real. So we have 2 real roots. So all you write is, therefore, delta greater than 0, roots are real. Alrighty, remember, ask a question. Why don't we put the square root? Because we are not looking at the square root of delta, we're just looking at delta. We're looking at b squared minus 4ac. Yes, it's the part that goes under the square root, but we're not going to work out the square root of it. We want to just see what the b squared minus 4ac is equal to. Okay, keep the questions coming, and I'm going to put the next one up, and now it's your turn. Do this one. Work out what is delta and then describe the nature of the roots. Put your answers in the chat. No, you don't have to say that. You can just say that the roots are real. Because if they're real, by implication, means they're rational or irrational. Yes, you must always, it's not a reason, but you're describing the nature of the roots. Okay, so give this one a go. And as soon as you have your answer, put your value for delta and then the nature of the roots as well. Okay, so some of you have worked it out already. We've got A is 2, B is 3, and C is -5. So we sub in 3 squared minus 4 times A times C. We get 9. and 40, and it's 49. Now look out for these perfect squares, because 49 is most certainly a perfect square. And we said that if delta is a perfect square, the roots are rational. So you write a little sentence here that says, therefore, delta is a perfect square. Therefore, roots rational, or roots are rational. Yeah, definitely watch out for the perfect squares. And they have to be positive perfect squares. But it's also greater than 0. So why can't we say the roots are real? Yeah, you can. It won't hurt to add it. Remember that if we go back to our diagram here, rational numbers are real. So if we've said that it's rational, then by implication, the roots are real as well. Right, next one. Let's go. Let's see this one. Work out the value of delta and then the nature of the roots. State what the nature of the roots is. Put your answers in the chat. Well done, everyone. Nice tries. Let's see some more people putting their answers up. We're almost 100 strong in this class, so let's get some more answers in the chat.
Have a go at it, guys.
Yep, that's fine too, Kirsten. You can say that it's unequal. Guys, do not take the square root of delta, just work out what delta is. So just say what your delta value is. B squared minus 4ac, don't take the square root on top of that. We don't see a square root here in our discriminant. We just see b squared minus 4ac, so we don't still go and work out what the square root of that is. Okay. So this is 1 plus 120. That gives me 121, and we have another perfect square. Delta is a perfect square, so you can say that the roots are rational. Yep. Yeah, you can say real, but you have to include rational. Roots are rational. And you can include that it's unequal. Okay, delta is a perfect square. Right, let's go to D. Don't get caught out by this one. Make sure you have the right A, B, and C value. So my A value is 3. We do not see, remember, standard form is ax squared plus bx plus c. We do not see an x term here, so my b is 0, in fact, and c is 5. I think some of you did get caught out by the fact that b is 0 and that b is not 5. So delta is b squared minus 4ac. So b is 0. You don't have to write that. You can leave it out. A is 3 and C is 5. And what we get is negative 60. And delta is smaller than 0. Therefore, the roots are non-real. Okay. Okay, make sure you understand why it's negative 60. And just fix your mistake if you thought that 5 was your B value. Many people make that mistake. Okay, so fix it. Why is B 0? Because we do not have an x term in our equation. Yeah, if there's no x, it means that the coefficient of x is 0, which makes everything 0. So it's not there. Okay, let's go on to question 2 before we have our brain break. The roots of the equation x squared plus 3x is equal to 4 are, okay, and then there's 4 options there. So what I want to know is what must we do first before we can work out what delta is? Put it in the chat if you know. We have to do standard form first. Okay, just like you would have done with your quadratic equation, you always, with your quadratic formula, you always first get your equation into standard form. Nice. And now you can do your delta and then tell me in the chat what your answer is, A, B, C, or D. People are saying C. We've got delta again equal to 25, so that is going to give us the answer of C, real, rational, unequal. Okay, well done, everybody. And okay, so let's go to our brain break. We do have, oh, I think I've got it here. It's unequal because delta is a perfect square. Okay, here we go. Here's our first one. Brain break. This is sort of gave me these to do with you. So as soon as you have your answer, remember we need to get to 24. So put it in the chat as soon as you get your answer. No one? Anyone?
Come on, guys. There's our first answer.
Nice, Latita. 7 minus 1 is 6 times 2 is 12 times 2. Or you can say 7 minus 1 is 6. 2 plus 2 is 4. 6 times 4 is 24. Nice. Latita wins that one. Kudos to you.
Nicely done.
Next one. Let's get some more people. Put your answers in. Come on, one more. Eight times 2 is 16. Plus 8, 24. Nice, Andile. Andile wins this one.
Nicely done, Andile.
Good stuff. If you want to get up and do a stretch, you're welcome to. Before we carry on with the rest of our work here. Okay, so let's see, we can make things a bit more interesting. We've got an equation here, x squared over 3 plus 3 is equal to 2x. And we also have to say A, B, C, or D. So we all agreed from the previous question that we need to get this into standard form. So what would the standard form for this be? Put your answer in the chat. Or put your hand up if you want to give an answer. What's the standard form?
Anyone who would like to talk us through it?
Right, Kensani. Tejo also got it. Kensani, you can unmute. Yes, Kensani.
So we're gonna take the 2x and take it to the other side, and then we're gonna write x to the power of 2 over 3 plus 2x, no, minus 2x plus 3 equals to 0.
Okay. And then Kensani, can you also tell us what is the value of A, the value of B, and the value of C?
I was gonna first like remove like the fraction before I did that.
Okay, so you want to, okay, yeah, we can do that. Before we do that,
Put me throughout.
what are you going to multiply by throughout?
3.
Yeah. So then we get x squared minus 6x plus 9. Do you agree?
Yes, ma'am.
Okay, and then we have, what is A?
A is x squared.
So in front of the x squared, we have a 1, so that will be A, and then B?
It's gonna be negative 6.
Negative 6, and C?
9.
9. 9. Great. Thanks, Kensani. Okay, so Kensani's done the work here for you guys. So now you can do your delta is b squared minus 4ac. Well done, Kensani. Thank you. B squared minus 4ac. And then we're going to see what delta is. We times by 3. Because if we times 1 over 3 by 3, we get rid of the fraction. Kaz has a question or maybe an answer. You can, there, Kaz is gone.
Hey, ma'am. So
Yes.
can we use, for the fraction, can we just put 1 over 3 as the A value?
Yes, you
We
can.
don't find out.
Yes, you
With other
can.
fractions, with other fractions, will it work the same? You just put the fraction in.
Yes, that's perfectly fine. So your A will be a third your b will be -2, and your c will be 3.
Okay, thank you.
Okay. So we should all arrive at the same answer. People are saying it's A. Let's see. So b is -6 squared minus 4a. If you multiply it by 3 right through is 1, and c is 9. And then I get 36 minus 36. And then delta is 0. So if delta is 0, we said that 2 equal real and rational roots. So the roots must be real and equal. And where were we doing that? Over here, real, rational, and equal. That gives you A. And if you chose to work with the fraction, where A is a third and B is -2 and C is 3, you would have gotten the same.
Well done, everyone.
Nice. Okay, next one, question 4. Some more maneuvering we need to do here to get it into standard form. What is 1/3 times 3? Those of you who are asking about removing the fraction, what is 1/3 times 3? That's 1. That is why we times by 3. But because it's an equation, we have to do it to each term. So we times the 1/3 by 3, and then the -2 by 3, and the 3 by 3. That's how we get x squared minus 6x plus 9. So that's why we do it. Okay, that same idea, you need now to do this one. Okay, so anyone wants to give me the standard form? Any other hands? Put your hand up if you know. What will be our standard form here?
Any volunteers?
Times x to each term. That's what Nosi says. And then we've got some hands. Nice. Andile, you can unmute.
Okay, ma'am, for the first one, we carry over the 5.
Yeah.
Then after that, we multiply by x crowd.
Okay, so then we multiply by the x, and what do we get?
We get 1 plus 2x squared minus 5x.
Minus 5x. Lovely. And now to get it into standard form, we just have to change the order around a bit. 2x squared minus 5x plus 1 is 0. Thanks, Andile. Right, and from here, it's easy to do our delta. Delta is b squared minus 4ac. Our b squared is minus 5. A is 2. And c is 1. And that's 25 minus 8. 25 minus 8 gives me 17. So delta is greater than 0, which is going to say that if we say that delta is greater than 0, if we go back to our notes here, 2 roots that may be rational, may be irrational. We don't know, not enough information if delta is just greater than 0. So real, rational, and unequal. Real, irrational, and unequal. So it could actually be A or B if delta is greater than 0, because it's just 17. We don't know more about it. We just know that delta is greater than 0, and for greater than 0, we have 2 real roots. Let's go, and it can be irrational or rational, actually. So, but delta is actually, let's go with irrational for B. Some of you said A. I'm going with irrational because we actually get delta is 17, and delta being 17, that's a prime number, and if you take the square root of a prime number, it's always going to be irrational, which is going to make your roots irrational. Okay. Right. One more, I think. Yeah, delta is not a perfect, 17 is not a perfect square. Okay, so let's do question 6. I think one more before we might be out of time. And let's get this one into standard form first. Okay, so work on it. And if you're ready, put your standard form in the chat so we can see what the standard form needs to be. Yes, Betejo, you can unmute.
Okay, so ma'am, the standard form I got is x squared minus 6x plus 5 is equals to 0.
Okay, so first we're going to multiply out the bracket, x minus 3 times x minus 3. And when we do that, we get minus 6 plus 9 is equal to 4. And then x squared minus 6x plus 5 is equal to 0. Well done. Exactly that. Did you go further? Did you go do delta?
Not yet, ma'am.
Okay, all right. Everybody, so check that your standard form is correct. Thanks, Patejo, for that. Check your standard form is correct. It's x squared minus 6x plus 5. So we have b squared minus 4ac. And that gives us 36 minus 20. And again, we get delta is 16. So it's a perfect square. And if delta is a perfect square, if we go back to our note, I hope you wrote it down or took a screenshot. So then the roots are rational and unequal. Unequal and rational. That's it. Question D. Answer D. Alrighty, I think that is all we have time for this evening. We still have to do our poll. Well done, grade 11s. You seem to be on top of your nature of the roots and getting there. Masana, the roots are only equal when delta is equal to 0. Remember, if you look at the 4 sort of classifications, delta is equal to 0, then the roots are equal. But if delta is a perfect square, the roots are rational but unequal. Alrighty, okay, well done everybody. I'm going to hand over to Ms. Lebo, who's going to do the poll with you. Stick around for that and please complete it. It was lovely being here with you this evening,